Welcome to Elemental Energy, the podcast where we discuss how to simplify decarbonization. Here, we will introduce emerging low-carbon energy technologies and give you insight on how to navigate and support the evolving energy landscape. It is our goal to develop content to give you confidence to help transition the market and make low-carbon energy reliable and affordable. I'm your host, Marcia Leonard. Everybody, I am so excited to welcome one of my favorite guests I think that I've had. I've been anticipating this for a while. He comes from the power generation space. He's been in it since the 80s. He's worked for the majors like Duke and Fluor and Worley, and his name is David Williams from Kiewit. I am exceptionally happy to have you here, David. Would you please go ahead and introduce yourself a little bit further?
Oh, thank you, Marcia. Yeah, when I started in this business, videos were done in black and white. We didn't have color. It was that long ago. I started as a 19-year-old co-op student designing nuclear power plants for Duke Energy. Right out of school, I continued that, and that's about the time, mid to late 80s, when the nuclear industry pretty much came to a halt. No new nuclear plants were started during that time frame. Universities had seen a tremendous drop off in nuclear engineering graduates from its peak in 1978 to the point where it dropped off all the way down into 2001. Less than a third of the nuclear degrees were being given out than had been at the peak in 1978. And my career kind of did the same thing. I got out of nuclear, stayed in generation, both with the utility and then on the contractor side, building whatever generation plants were being done at the time: pump hydro, coal, gas, even moving into renewables before we saw a renaissance of nuclear start coming back. During that time, me, like many others in the industry, if you stayed in nuclear, you were working at an operating nuclear plant for the most part, or you're working overseas. You weren't working in North America. You washed your resume of anything that said nuclear. Nuclear was a bad word. It did nothing for your resume other than perpetuate costs and schedule overruns and very inefficiency, and not what new generation was all about. New generation was all about get them done quickly, get them done at the lowest possible cost, the most efficient means possible. So you washed nuclear from your resume. I stayed in the generation sector for most of my career. Moved out of engineering and moved into business development in the mid 90s, and really have been in mid management, business development roles ever since. I have dabbled a little bit outside of just generation, a little bit of transmission distribution, a little bit of communications, a little bit of gas pipeline work, but mostly generation. When I came back into the nuclear generation, Mark, when Kiewit hired me to lead their commercial nuclear business development at the start of this year, in January of 2023, I've seen a rebound in the entire industry, and it's really driven by small modular reactors. And we can talk all about kind of the history and how we got to being with small modular reactors as being the energy of choice when it comes to new nuclear generation, and why that is, and what the technologies are about, and the interest we're now seeing in the industry, and the reason Kiewit hired me, and we're doing a significant number of hires to support this industry. So very exciting times. Got nuclear back on my resume. It's no longer a 4-letter word. It's going to be a part of the mix moving forward. I'm going to spend the rest of my career trying to help do just that, is put new nuclear generation in North America.
David, before we even get started, we're going to explain what new nuclear is and that term and what's going on in the market. But I typically like to start off with like a did you know session about climate change, because let's face it, the reason new nuclear is having a comeback is because we've all taken the time to recognize that we are having an impact on our climate, and it's due to emissions. So typically I do like a hot seat did you know, but I've come up with something very special for you.
Okay, good.
Because you and I speak the same language of humor. And I hope that you could laugh at me and with me on these. So, David, I'm going to tell you a few jokes about climate change. David, Have you noticed recently that all the weathermen are blushing?
I have not.
It's because they're watching climate change. Oh, it gets worse. Just bear with me.
These are like stupid dad jokes. This is right up my alley.
I know. I figured you would laugh with me or at me, whatever. Okay. So I'm really happy that you're here today because we're talking about one of the solutions for climate change. We haven't really figured out a solution for climate change, but I hear we're getting so close. In fact, we're getting warmer.
Bum, bum. Well,
Yeah. Okay. I promise I'm almost done. Okay. When I first started, I came from an oil and gas background. And then I started to get into this power generation side of things. And I really did not believe in climate change. I thought it was like a cyclical, the earth goes in cycles. But now that I've been really researching it, I'm starting to warm up to the theory. I promise there's only one more, just one more. Okay, so let's talk seriously really quickly, David. Let's be real. You chose to build your retirement home in the Carolinas because you knew Florida was going to be underwater, didn't you?
Genius. Genius move. Absolutely. Yeah. Climate change obviously is a very politicizing topic to talk about, and I choose not to get into politics and try to dwell too much on it. However, there is such momentum now from both sides of the aisle that we need to do something about the carbon emissions that we each have a hand on, right? And as a country, as a globe, we need to reduce carbon emissions. Whether or not that's going to have an effect on climate change or not, we're not going to know for hundreds and hundreds of years. But if there are things that we could be doing to reduce carbon emissions, why not do it? As long as we're not bankrupting ourselves or bankrupting the planet, why not? There's no good reason not to. And so there's enough momentum. And like I said, it's moving beyond politics now a little bit, I'm seeing, because we are seeing both sides of the aisle. We are seeing some of the most conservative countries, some of the most liberal countries, both coming together to say we need to do something. And what can we be doing? And nuclear energy can play the biggest role in that. And nuclear energy produces zero carbon. We all know that. The scare of nuclear energy, to me, is unfounded. And we can talk all about how we got to where we are from a standpoint of why nuclear costs so much to put in new nuclear generation. It shouldn't cost that much, but why does it? All right. And it's a lot to do with people just being scared and not understanding. So I think what the industry as a whole is moving in the right direction with small modular reactors. So we could talk a lot about that and why that is and why that holds a little bit more promise than we saw during the previous renaissance from 2005 on, where we were kind of disappointed in how things came about.
You're absolutely correct. It is highly politicized. And all joking aside, honestly, the reason I want to even bring up climate change is because people do need to start looking into it and researching it. And that's why we are where we are in the market today, is because large corporations and companies are all working to focus on one goal, and that's emissions reduction. And that's why you and I are here to talk about new nuclear. So, David, help our audience understand, what is the term new nuclear?
So new nuclear, let's talk a little bit about what old nuclear is. So nuclear came about from World War II. As we all know, there were a couple of bombs that were put off that demonstrated the vast amounts of energy that can happen from nuclear fission. And so the next wave was the nuclear fleet in the U.S. and certainly in other countries started realizing, wow, we can power ships and submarines using nuclear reactors, using the same fission process, and we don't put out emissions, and therefore we can float underwater and go vast amounts of places without putting off an emission stream. And so nuclear energy moved into the marine base. And then from there, the utilities started saying, how can we harness this energy source to produce electricity as an energy source? So it kind of moved from the marine to the utility grade, Well, the utilities wanted to build the biggest possible reactors they could because they have the lowest dollars per kilowatt hour produced. So they started producing these huge reactors. The manufacturers started producing reactors and, 500 megawatts, 700 megawatts, 800 megawatts, up to 1200 megawatt reactor sizes that would you turn on, and they had 96% availability. They ran 24/7. You turn them on, you crank up the most electricity as you possibly can for any given unit size. And that was all well and good until we started finding out that those things were just too expensive to build. To stick build those reactors with the regulatory requirements and delays was just too expensive. And we discovered that with the building of the 2 units at the Vogel station in Georgia and the attempt at 2 new units at the BC Summer Station in South Carolina that ended up halting construction due to the length of time and the astronomical cost increases that the industry was seeing. So the entire industry was watching this happen and saying, we need to figure out a better way. And so back in the early 2000s, companies had started thinking of small modular reactors, reactors that you could build in a factory, ship to the site, weld them in place, turn them on, and they start producing electricity. So they have to be small enough in size to be able to do that. And so a lot of companies started developing technologies, and most of them were scaled down versions of the larger reactors. So a large light water reactor, you could scale down and make it into a smaller size, small enough that you could build it in a factory and ship it to the site, versus a large reactor that required a lot of construction hours on site, a lot of welding outdoors, a lot of outdoor labor in the elements, and in less of a controlled environment. So new nuclear to me means smaller, to be able to deliver on certainty of cost and schedule is really the big thing that's been holding nuclear back for the last 30 years is certainty of cost and schedule. It's not about safety. We are getting safer, which is part of it. And these small modular reactors are designed with a whole lot more safety, fail-safe types of design characteristics to them than the larger reactors were initially. Most of the large reactors are now just as safe as the small modular reactors going forward. But that's to say that they are smaller, they are just as safe, if not safer. They can be more predictable from a cost and schedule standpoint. So that's when I say new nuclear, that's what I'm talking about.
I want to clarify this even further because you said it and you touched on it that these new nuclear technologies, they're not necessarily new technologies. We have PWRs, which stands for pressurized water reactor, BWRs, boiling water reactor. And these technologies have already been out there. They've been around for a while, but we're taking those big ones and scaling them down and condensing them into smaller. So it's not necessarily new nuclear, correct?
Yeah, exactly. Most industries start small and you're scaling up. And when you scale up, you run into problems with scaling up. We don't anticipate running into those problems scaling down. You're actually getting rid of issues when you scale down. So yes, it's going to be from a standpoint of you're producing less megawatts for a unit size than you were with the larger ones. But if we can build these things on a predictable cost and a predictable schedule and reliable outcomes for the financial community and the ratepayers that are having to pay for these things, we can build a lot more of these and get the same amount of megawatts, but you're going to have a lot more confidence in the cost and schedule.
So I want to expand on that a little bit further when it comes down to the application of these SMRs, because there's utility space, obviously, for general power generation in communities. But we are seeing the application of these things go even as far as being placed on offshore oil rigs. There's feasibility studies being performed right now. So I kind of think of it as a portable, much more condensed, like power pack that you can plug on to different applications and different industries and assets. I mean, what are some of the other applications for SMR that we are trying to break into?
Yeah, the other great thing about the SMR being a smaller size is now all of a sudden, let's take an island community that has not to date been able to use nuclear energy because the unit sizes are just way too large for what they need, and they can't generate the amount of electricity they need, because they would be forced to generate a lot more, and therefore they were precluded from participating in nuclear generation. Now with small modular reactors, you could look at an island nation, you could look at a Caribbean island, you could look at an island in the Pacific that only needs 30 megawatts or 70 megawatts or 50 megawatts of electricity. All of a sudden now they can play in the nuclear space. They can now have a nuclear reactor, and whether you put it onshore, whether you put it out on a platform. I'm even hearing people say, wait a second, we've had nuclear submarines operating for 60 years. Why can't we just put a submarine right offshore, go ahead and sink it to the bottom, wire the electricity in like you would on an offshore wind project, and you have safe, reliable electricity being generated by nuclear fuel? Why not? So there's all kinds of options. You're also seeing, let's say there's an Army base that wants to be grid independent, wants to be completely able to generate electricity to support its base operations, but be off of the grid. Well, now they can use a small modular reactor. They may only need 50 megawatts or 70 megawatts to operate their base. They can be grid independent and carbon free with reliable nuclear energy. That, to be carbon free and to be reliable is very difficult for the renewables to meet. They have to have storage, and that brings a lot of inefficiencies and a lot of costs that a new nuclear plant with a small modular reactor just doesn't bring. So there's a lot more options now. A lot of large industrials need 50 megawatts to operate their facility, and thus, for the most part, they've been using fossil fuels to do that. Like you mentioned earlier, they are being driven to reduce their carbon footprint as well. So how can they operate and generate electricity carbon free, yet maintain the availability and reliability that they need to be able to operate their facility 24/7 around the clock? So nuclear has an opportunity to play a role there that otherwise they couldn't play previously.
Excellent. Excellent answer. I didn't even think about the Army base and kind of those applications. So thank you for sharing that, David. I I want to ask you a question when it comes down to the construction of these old or these traditional nuclear plants. What was Vogtle? $26 billion TIC. I mean, it was something
Yeah,
ridiculous,
they,
right? Around there.
yeah, the original price for Vogtle 2-unit plant was 14 billion, and they're probably going to be north of 30. I think the latest number I heard was around 34 billion. So I mean, at $16,000 a kilowatt, that doesn't even compete with any technology. I mean, that is way out of bounds from any type of technology. $16,000 a kilowatt compared to, let's say, a natural gas combined cycle plant at less than $1,000 a kilowatt. Do the math. I mean, it's astronomical cost to get a kilowatt of electricity. Yes, it is carbon free. We understand that, and it is reliable. It's going to operate, and it's going to run 96% availability. But it's going to bankrupt companies. People are going to jail because of the cost overruns at VC Summer. It's not a happy story. And again, like I said, the entire nuclear industry wishes that was not the story, but it has opened the door for more acceptability of small modular reactors. And I do believe that we're going to see a big push here in the next 10, 15 years of small modular reactors, not just in North America, but really all over the globe.
So I'm very excited to ask this question of you because you have that contractor background, and I want you to help educate me coming from an oil and gas background. I look at these large projects and I've helped deliver major projects like this, and it just takes a strong project management team to be able to put something like that together. Why is that culture not the same in the utility space? I mean, what really was I'm going to get to the point of with
Yeah.
these small modular reactors, I've seen the trend that they are now accepting these integrated project delivery teams. Like they are finally getting on to with the way oil and gas jobs were typically performed. Why was that not the case beforehand?
Nuclear suffers a huge black eye, especially in the United States, because of the Nuclear Regulatory Commission. Back when the first round of reactors were being built in the 60s, 70s to through the mid 80s, you didn't really have a Nuclear Regulatory Commission that was hindering you, for lack of better words. They were helpful. The regulators at that time, it wasn't called the NRC, it was called something different, but they were there on site to help you. To help you uh, meet the design, make sure that you're constructing to the design specifications, helping you meet schedule, helping you get costs under control. And that changed. And it really was for the industry pretty much shut down for 30 years. The Nuclear Regulatory Commission was formed at about the time that there was no new nuclear plants being built. So they didn't have a lot of firepower behind them. And when the nuclear renaissance came along, they kind of had to reinvent themselves. And they have not been able to be as helpful as an industry as they needed to have been. I think that's going to change. I think they are seeing some change. I think they realize that as a country, we have to be able to produce nuclear power generation if we want to compete on the global market, but also if we want to do what we're trying to do, which is meet these carbon reduction goals that we as a nation and different companies have put out there. So the oil and gas industry has never had to live with that. They are basically building their plants to specifications. Yeah, they're regulated, but not to the extent that Nuclear Regulatory Commission regulates new generation when it comes to the nuclear power generation. So I think that's the primary reason. The secondary reason is, the ratepayers that are paying for this electricity feel like they have all kinds of other options. Whereas a Dow Chemical, let's say, decides to go build a new chemical plant, they've got their own marketing research. They've got customer base that they base their business plan on that doesn't include an electric rate base person who has options on where they want to get their electricity from. So I think there's a lot of things that have affected the nuclear industry, but for the most part, I would say it's the cost and schedule uncertainty. We always come back to that. What can we do as an industry to ensure better cost and schedule certainty for these nuclear power plants? And I think SMRs are a step in that direction.
Okay, I think that we've touched on traditional nuclear enough now. I really want to get into the future. And a lot of people don't understand, like, our role as business development professionals. It's not just to go out and make sales. It's truly finding a solution and helping build operational teams to deliver these projects in a different manner and to help make them more affordable, because nuclear is already reliable, it's clean, but now it's up to us to help lay groundwork to make it more affordable. Correct?
It is. There's still traditional nuclear light water reactors still have one major flaw outside of just cost and schedule, and it's the waste. The waste generated, the nuclear radioactive waste that is generated by traditional nuclear generators is significant, and we have to be able to store that safely for decades and decades so that radioactivity dissipates to a point where we can now safely dispose of it elsewhere. But for the most part, that means underground caverns somewhere. And if you try to do it in a central location, let's say in the United States, and the federal government decides to find a place to deposit this nuclear waste, you still have to transport it there, because you're generating it from all over the country. And now you got to put it on the roads, you got to put it on the rails, you got to do some way of getting it to that. And so you've got highly radioactive waste concerns that the new technologies outside of the light water reactor technologies that we've traditionally used are trying to address that. We've got what's called fast reactors that can be a lot more efficient in how it uses fuel and how it produces the fissional material, so that you don't have to refuel as often, you don't have as much waste fuel, you are able to use more of the fuel. Some of the technologies can actually refuel themselves, so they're breeding fissionable products as they run, and so you might not have to have a refueling outage every 18 months like you do now with a traditional light water reactor. You might be able to go years and years and years, if not for the entire lifespan of the plant, never having to refuel, which that's fantastic, right? So far less waste to handle. Those technologies are being developed. They've been under development. There are test reactors for fast reactors that have been going on for years and years. We believe the technology is ready. And there are some commercial applications in the forefront. Our company is working with several of those manufacturers to figure out, okay, who's a customer and where you need a customer host. You need some utility to stick their neck out and say, I'll be the first. And utilities are, in general, they don't like to do that. Utilities in general are very conservative. They want to go with known technologies, proven technologies, something that they can look at their board and their ratepayers and say, we're not going to put you on the hook for something like the ratepayers in South Carolina got with the failed VC Summer project. So they're going to be very conservative, known technologies, but those technologies are coming about to try to address the concerns. We talk about cost and schedule certainty. SMRs can do that. We start talking about the nuclear waste issue. Fast reactors are moving a long way toward that. And then further down the road, if we can ever figure out how to harness fusion, nuclear fusion, which is what the sun produces, all of a sudden now you don't need fuel anymore. You just basically turn it on and it runs for life and it's producing free electricity. And it goes back to one of my mentors, Bill Lee, who eventually became CEO of Duke Energy back during the first nuclear wave back in the mid 70s. He was the head of the design engineering department at Duke Energy. And with his very Southern drawl, he said, nuclear fuel is going to be too cheap to meter. In other words, you wouldn't even have to put a meter on the house to find out how much electricity people were using because it was being produced so cheaply. It'd be too costly to put meters on houses. That's how the dream of nuclear energy was until it came crashing down in the late 70s. But hopefully we can get back to that. And fusion has an opportunity of providing that type of dream. If we can start generating electricity the way the sun does it, guess what? We've got all the energy we'd ever need for the rest of our lives.
It's going to happen. So I think it's going to happen sooner than later because of how many people are so passionate about this subject and bringing it back to light. What is your opinion on the timing of some of the first SMRs here in the United States? Canada is one of the closest, like they're a little bit further ahead than we are in the United States. I mean, there are already SMRs operating in China. I believe it's Russia as well. But what do you think time-wise we will have the first SMR up and operating here in the United States?
My guess is it's 2030 to 2032. My guess is it's going to be in Tennessee. You mentioned Canada. So Ontario Power has been the leader in Canada, really in North America, for trying to push new SMR technology. And they've got a project underway at Darlington, which is up on Lake Ontario. Or Lake Erie, I'm sorry, in Ontario. They've announced one unit earlier this year. They picked the GE Hitachi BWR X300 technology. That's a mouthful, but it's basically a 300 megawatt unit size. They've picked that as the first SMR that's going in North America. They've already started the project. The contract is underway. It is an integrated project delivery contract, just like you mentioned earlier, which is Ontario Power says that's the way we want to do it. Ontario Power has formed a collaboration agreement with their former CEO, who happens to be the CEO at Tennessee Valley Authority now, Jeff Lyash. And they have said TVA and Ontario Power want to share in resources. They want to share in knowledge. They want to share in helping each other deploy these SMRs. TVA is going to probably be a year and a half, 2 years behind Darlington. But they do have a collaboration agreement. They're using the same technology. They're trying to make sure they do it the same way. So TVA is also a proponent of the integrated project delivery model, which we can talk a little bit about, but it's just a new way of doing business for the power industry. As you mentioned, it's been used in other industries successfully, but it's a way that all the parties understand we got to share in the risk, we got to share in the rewards, but we got to work as a team to get these things done. Just today, Ontario Power announced they're going to not just do one unit at Darlington, they're going to do 4 units. So 3 additional units getting started at Darlington. Jeff Lyash at TVA has been quoted recently saying, I don't want to do one SMR at our site, at the Clinch River site in East Tennessee. I want to do up to 20 to 30 on our entire system. So that's where you're going to see the most momentum, I think, initially is at the Clinch River project, and TVA is doing it there in East Tennessee near Oak Ridge. But there are several other utilities that are knocking on our door. There are several other utilities that are collaborating with the equipment manufacturers and trying to figure out what's the best equipment for themselves and moving forward. And GE Hitachi does not have the only SMR technology that's ready to go. NuScale, which is a smaller modular reactor, more 77 megawatts compared to 300 megawatts, and may give them some flexibility to site their plant where someone doesn't want just 300 megawatt unit size. They want more flexibility with a smaller nuclear size. NuScale's SMR is the only one that the design is already certified by the Nuclear Regulatory Commission. So they have a certified design ready to go. They just need a customer, and they've got a customer in Idaho. Utah's Municipal Power Association, UAMPS, has cited Idaho Falls, Idaho, is where they're going to put their SMR project. So that one's underway as well. Will it race ahead of TVA? Well, is it going to be slightly behind TVA? It's a toss-up which one of those goes first. There are a couple of other projects underway that could also compete with being the first SMR. So everybody's watching. Everybody's not jumping all oars in the water, but they certainly are dipping a tip in to see what it feels like. So everybody's looking at SMRs. Everybody's looking at different ways of using the nuclear generation fleet that they've got to help meet carbon emissions demands. And we'll talk probably some about what's pink hydrogen, for instance, and that, I'm sure that's somewhere where you wanted to go down, because I know your company is very, very invested in the hydrogen market and what hydrogen can do to help us with carbon reduction. There's a way of doing that with nuclear energy that is very exciting, and Constellation is a utility that owns more nuclear generation than any other utility in the country, and they've already started doing a pink hydrogen demonstration project at their 9 Mile Point nuclear plant in Oswego, New York. And so I think you're going to see some other nuclear generators saying, hey, when it's maybe low electricity sale time, like at night, where I don't necessarily need to generate all my electricity up from my nuclear plant, why don't I make a little hydrogen on the side? And you can store that hydrogen and you'll have it ready to use for a number of different applications where carbon fossil fuels were used in the past. So there's a lot of innovation going on right now in the entire industry, including nuclear, to find ways of helping everyone reduce their carbon footprint.
That is brilliant. Thank you for sharing that tidbit about Constellation. I didn't know they already had a pilot plant in process. It's funny how your brain thinks very similarly to mine, because you started going down the path of some of the companies that are out there in the SMR space. So in my opinion, some of the most advanced right now, Westinghouse, GE Hitachi, NuScale, followed up by like TerraPower, the Bill Gates company, where they're actually talking about utilizing spent nuclear waste in their reactors. Like, explain to me, how are we going to support one customer to really help them make economies of scale and speed to market? Like, how can we hyper focus on one of the most advanced technologies and help build them up? Because I feel like there's a lot of static with that many different players, SMR technologies out there. How can we really help hyper focus on the ones that are making moves? I mean, it's kind of, what I'm trying to ask? It's like, there's so many technologies out there.
Our industry, the electric utility industry, has always had a herd mentality. One utility steps out and starts doing a nuclear plant, the others watch and say, we need to be doing that too, or we're going to be accused of not being innovative, and our customers are going to get angry with us because we're not being innovative and trying to find cheaper and safer and better ways of producing electricity. So there is a herd mentality. Everybody's going to be watching what TVA does at Clinch River. Everybody's going to be watching what UAMPS does at Idaho Falls. Everybody's watching where TerraPower's got their first project going in Southwest Wyoming. They're watching what's happening there. They're wanting to see predictable cost, predictable schedule. They're wanting to see the operating flexibilities that SMRs bring. We didn't even talk about that over traditional nuclear. So there's a whole lot of advantages to SMRs, but there's also the herd mentality that's not going to go away. You do need someone to stick their neck out and sponsor the first one. But if successful, you're going to see mass amounts and more of them put in. And quite frankly, we can't build enough of them to satisfy the carbon reduction goals that as a country we've laid out, as many utilities have committed to, as many other industries leaders have committed to. Uh, we're not going to build as many as we need. So we need that herd mentality to come. We don't have to figure out which ones are best because they're all going to get built. They are all going to get built. The manufacturing supply chains not going to be able to supply it from one manufacturer. So all of these companies need to be successful, and we're going to. Our goal as Kiewit is to try to sponsor as many as we can, try to support as many as we can, not having to be the predictor of which one's going to happen first. They're all going to happen. There's really not a fatal flaw in any of these technologies that are ready to go commercial.
So, David, I see a part 2 of this podcast and yours in my future. But I want to, one of the last topics I want to discuss, it's actually a concept that you enlightened me to last October when it comes down to spreading the safety surrounding nuclear. You told me that nuclear is one of the safest power generations out there, but it has a stigma because I had the perception from 3 Mile Island, Fukushima, Chernobyl, because when it impacts like immediately and at a large scale versus other power generation sources like renewables, oil and gas. They're, I don't want to say death per kilowatt, but like when it comes down to how many injuries kind of surround the other energy productions, nuclear is really low, and there's a lot of data out there to support it. So it's kind of a perception shift that you introduced me to. Can you just elaborate on it a little bit further and help other people understand that nuclear is safe?
So, I'm old enough to remember 3 Mile Island, okay? And what people your age don't really understand as much is 2 months before the 3 Mile Island accident in 1979, there was a movie that came out in Hollywood called The China Syndrome. And it was Jane Fonda and it was Jack Lemmon. So it had some big hitters. And it was all about the concern of nuclear energy and what would happen if a reactor actually got into a meltdown situation and was uncontrolled and could be disastrous. And it actually could be. There's no doubt about it. It did not help the nuclear industry that 3 Mile Island accident happened right 2 months after that movie was released.
13
So
days.
it just
David.
verified people's scare. And again, I was alive then, and I was certainly understanding what was going on. I didn't understand the lasting impact that would have on people because no one was injured in the 3 Mile Island accident. Certainly no one was killed. No one picked up any more radiation than you would pick up on a cross-country airline flight, for instance. So it was a perception that what could have happened. Now, what did happen is that nuclear reactor was shut down forever. So there was a huge cost impact for shutting that reactor down, for keeping the decaying radioactivity from escaping, and for safely being able to get rid of all that waste. And that reactor never produced another kilowatt of electricity in the rest of its existence. So there was a huge cost impact, no doubt about it. But the safety concerns were certainly exacerbated, and in part because of the China syndrome. Then you jump ahead to 1986 and the Chernobyl accident. And, that was a Russian technology that they didn't necessarily have the same safety concerns that we have in the US. But we as a nation and as an industry knew we needed to step in and try to help understand what actually did happen. And so we actually helped sponsor a new organization called World Association of Nuclear Operators to come in and let's find out what happened at Chernobyl. Let's not point fingers at the Russians and say you're bad people. An accident happened, people died. There was significant radiation leak, and it showed the possibilities of what can be disastrous from nuclear energy. And then you jump ahead to Fukushima in 2011. And, in every case, you look at it and say, wow, if they'd just done this, if they had just done this, if they just had this in place. But you learn those lessons and you apply those so that particular situation could not happen at your nuclear plant. And so you had a lot of post-TMI, 3 Mile Island design modifications that were put in at every nuclear plant You had some post-Chernobyl modifications. You certainly had post-Fukushima modifications. As an industry, you're learning what can we do to make sure that it truly is the safest way to generate electricity. And the stats line it up. There have been more explosions at coal-fired power plants or gas-fired power plants that have killed people than ever in the nuclear industry. But the potential for nuclear is so much more intense and so much of an emotional subject matter that it's still very much a stigma for the industry until you start pulling the layers back and really digging into it.
A piece of mind that I've learned over time with the transition into the space is radiation is measurable with a Geiger counter. You can't go out and determine, chemical pollution or air. I mean, you could determine parts per million in air pollution, but Geiger counters are very easy to actually determine if space is radioactive or not. So that was something that put settlement on my mind as well, to where something really happened. They could measure it very quickly and very easily. So David, you and I could talk about this subject all day, but I do want to save us for a part 2 at some point in time. And I want to leave you with a piece of my mind, what you have been doing in this industry. I look at myself as a third generation of you, because you have taken the time to pour into Max. Max has taken the time to pour into myself. And I've had the experience of being able to get a little bit of insight and learning from you, but I have a very different generational insight and knowledge, and having your help pour into that and grow that, you're leaving a huge impact on this nuclear space. So you talk about, we were joking around about retirement earlier and everything else, but like what you have done in this industry is amazing as a business development professional, and what you're going to continue to do. And I want to empower you and tell you to keep doing it until you can sit back in 2032 and be like, oh, look, there's an SMR in my backyard. I'm so proud to know you and to have everything that you've done with David. So I appreciate you, and I appreciate your time today.
Well, no, I thank you for those kind words. And if your podcast was called anything other than elementary, I would probably had to pass on it, because I am not a nuclear expert. I can talk at a very high level just to give a little bit of credence to open a door. But I'm kind of like Mona Lisa Vito in the movie My Cousin Vinny. I'm an automotive expert. I'm an energy expert. But I can talk through it, and I can give my opinion on certain things. But I'm not an expert down to the level of really understanding what's the difference between a fast reactor and a light water reactor, and fissionable products, and U-235 and uranium-238 and plutonium-239. Those different atoms. I know you throw neutrons at them and split them up and energy comes off. I know enough about that to be able to understand that's what nuclear energy is, but I'm not an expert. But I have been in this industry a long time. I have seen a lot of the ebbs and flows. And I talked about the nuclear energy, the degrees. The nuclear energy in the United States really started in the early 60s. Universities started nuclear energy engineering programs. And you look at how many degrees were given out in 1966 compared to how many degrees were given out in 2001, it was almost double. So from 1966 to 1978, it basically tripled. And then it came all the way back down to 2001, was kind of the nadir on the low side, but it's coming back up. And so we're now giving degrees out back almost at the same level as we were in 1978, which tells you the younger generation, the Marshall Leonards of the world, are embracing nuclear. Nuclear is cool again, right? You can go into nuclear engineering and you can obviously get a job. That's not a problem. We can't hire enough nuclear engineers right now. There are not enough available. But it shows as an entire industry that things are ramping back up, that the younger generation's embracing it, and that's what we need. So nuclear is good. Nuclear can be safe. It is safe, and it's going to continue to be safe. We just got to make it affordable and predictable from a schedule standpoint. And it's going to be the answer to everything we're looking for right now in electricity generation and other carbon-free reduction goals for other industries, transportation, chemical production, whatever it might be. Everybody is trying to reduce their carbon footprint, and it's good, and nuclear can play a role.
David, on behalf of myself and all of the elemental energy listeners, we really appreciate you and your time. And that's what we are here for, is that elemental version of this, to help people get an understanding and a basics, and then they can take off down the rabbit holes to see the different technologies. But I want to sign off to everybody and say, stay safe. And most importantly, stay happy, because I truly believe the reason David and I are going to live to be 100 and have beautiful laugh lines on our face is because we love to laugh. We love to see humor in life. And we hope we shared a little bit of that with you today. So, am I right, David?
Thank you, Marsha. And keep doing what you're doing. This is fantastic forum. I've watched every one of your podcasts so far. Sorry, it took me a little bit of time to get on your schedule. And that was mostly my fault, because I knew you had me elevated from a nuclear perspective a lot higher and a lot earlier. But keep doing what you're doing. It's fantastic. Anything I can do to support you, I'll do it.
I appreciate it. You take care. Have a wonderful weekend, David. And we'll talk sooner or later, okay?
See you later. Bye.
Thank you all so much for listening today. If you enjoyed this podcast, be sure to subscribe so you're notified every time a podcast is released. Find Elemental Energy on Facebook and connect with me, Marsha Leonard, on LinkedIn. But lastly, and most importantly, share this podcast with your family and your friends, especially if you are in the energy industry and you're having an influence on the path of decarbonization. I'm on this journey figuring things out, and I want you guys to come along. So the closer I can get to you and the more I can connect with you, the better this show will be and become.
Where are you? You're not at Whitefish Lake, are you?
You ready?
Yeah.
This is about to earn your title if you can guess where I am at, and this is solely for you.
Holy cow, look at that.
Do you recognize that floating green?
You're at, it's a French name, D'Elaine, something D'Elaine.
Coeur d'Alene.
Coeur d'Alene, that's it, Coeur d'Alene. I knew it was a big resort in Idaho. I've never been there, but I've heard about the floating green.
The only one in the United States. And I'm here because I was like, oh, he will totally know, I'm sure, where I'm at.
Way to go.
Oh, awesome. See, that is exactly what I had anticipated it to go. And it was so funny because you were literally reading my mind of questions that I had next. Like, I'm
People are going to think we had a script, aren't they? Yeah.
Oh, 100%. This is one of my favorite episodes that I have recorded to date, other than Maxwell Powerhouse Pitches.
Well, Powerhouse. Now, nothing's going to ever replace Powerhouse.
Oh,
That's awesome.
And as far as supporting it, if there is anybody else that you think that I should interview, or that you could help me get an interview within the nuclear space, that would be really appreciated, because I've reached out to a couple of CEOs in the SMR technology space. And I want to bring somebody in to talk a little bit deeper, but still kind of the same high level, very easy conversation. So if you have somebody in mind,
Okay.
that would be a good, because it's beneficial for everybody, quite honestly. So
I will do that. If I can think of anyone, I'll let you know for sure.
thank you.